Hello, so today I'm going to be talking about a modification of Fitts law. It has an extra F and it talks about modeling finger touch with Fitts law. So if you don't know Fitts law, it's one of the most robust and successful models of human motor behavior. The equation is on the top right, where T is the average time taken to complete the movement. A is the distance between the starting point and the center of the target. W is the width of the target, and A and B are constants. Reflecting the efficiency of the finger movement. So talking about Fitts law for small target activation, it has been proven to be insufficient with finger touch based input on screens. So usually it was used in UAs where we talked about keyboards and everything like that, but with finger touch, it has been insufficient. So this paper proposed a dual distribution and hypothesis to interpret the distribution of the endpoints and finger touch movement. So they said that this distribution is actually the sum of two independent natural distributions. So one of them is relative precision governed by the speed accuracy trade-off rule in the human motor system. And the other one represents the absolute precision of finger touch independent of the speed accuracy trade-off effect. So they conducted 3 experiments in 1D target acquisition, 2D target acquisition, and also a touchscreen keyboard typing tasks. So more about the experiments. In 1D, they had a simple task to touch a target bar on the smartphone of varying sizes at each child. So specifically, there was a starting point as a bar and then a task and a target bar. So the target bar could be of different sizes. Maybe it's like a button or different sizes that fits on a smartphone UI. Each participant did 16 trials and their modification outperformed the Fitts law with an effective target width. 2D tasks were the same as the front D tasks, except there were solid circles and W values were diameters. So Fitts law, again, the modification was the strongest fit. To further discuss this apart from 1D and 2D tasks, they decided to check modeling text entry behavior on a touchscreen keyboard. So participants were asked to type a word 4 times, and the modification yielded the strongest fit amongst 3 models. So it's a lot of theory that I haven't mentioned, but the way they tested was there are 3 different types of test models. One of them was the Fitts with an extra F, which was their modification, which is the top right that you see, where sigma is the standard deviation of the touch points and sigma A is the absolute precision of the input touch finger. So this was the one that they mentioned, and as you can see, it outperformed all the tasks. It outperformed Fitts law in all of them. And the 2 test models of the original Fitts law they used, one of them was a nominal width and the other one was an effective width. This is a great paper to start if you ever want to learn more about Fitts law and also the different types of nitty-gritty it has with finger touch, because they talked about how finger touch movements is insufficient for the original Fitts law because of the fat finger problem and other things that have happened ever since we have come across the PC. We've extended from the PC situation. So yes, it's a great paper, and I try to make it as short as possible. Sorry. Okay, thank you.